So it's my pleasure to introduce today's speaker, Professor Dr. Eugene Schultz. Gene got his PhD actually from Purdue many years ago, and he has obtained since then too many awards to enumerate. Let me just mention the faculty positions he has held at such places as University of North Carolina at Chapel Hill, at Berkeley, at Caltech, and he also worked with SAIC and has won many awards and spoken at the very best venues. It is really our pleasure to have our alum back, and he also spent 3 years with us here from 1998 to 2001. We had that pleasure and honor of having him here.
Thank you.
And he's going to talk about intrusion detection.
Okay, we have those slides on? We okay? Ready to roll? I'm here to talk about intrusion detection, event correlation, approaches, benefits, and pitfalls. What I'm going to describe to you in as few words as possible is how is it possible to take lines of research that are being out there, published out there, and make them your own, actually apply them and use them in something that you can use in real life situations. And I work for Hightower Software, and I'm the Chief Technology Officer, and if I didn't have an academic background, I'm quite convinced that what we do at the software company wouldn't be nearly as good as if I didn't know the kind of things that I'd learned out in the academic arena. And I went to the CERIAS website today, and I found a very interesting statement. It said the area of event reconstruction and computer forensics deals with analyzing and evaluating data obtained from a system and use it to determine what happened. The data recovery process is a well-covered area within computer forensics, but little work has been done on how to actually analyze and evaluate the data. Only very crude tools such as MAC times and individual log analyzers exist. Now, this was a student's master's thesis several years ago, and I contend with you that what was written here 4 or 5 years ago isn't true today, that there have been huge advancements in terms of being able to understand exactly what happened when attacks happen, when there are denial of service attacks, when there's malicious code attacks, when you have hacker attacks, when you have insider attacks. And as one solution to the problem, we have network-based intrusion detection. And network-based intrusion detection means basically that we look at the traffic that goes over the network. We have some way of recording the data from packets, and then we try to determine whether any of the commands that have been sent over the network or any of the data that have been sent over the network match any known patterns of attacks. And these are often known as signatures. And if the signature library contains an entry that matches what went across the network, then some kind of alarm, usually in the way of email, is issued to the intrusion detection monitoring people. And so, for example, in this case, this is a pretty simple attack. What somebody is trying to do is connect to what in Windows systems is known as an administrative share. Administrative share allows you to do things like make updates to Windows systems, to be able to do things like change the configuration. And netuse star / 128.8.45.139/C $ means all I have to do is enter the password of any administrator on the system, and I get access to this share. Oh, by the way, one of the limitations of security here is that there is no limitation for bad logons. I can keep trying to enter a password here until you know what freezes over, and I will not be locked out from trying to connect to the share. Now, there's a widely used intrusion detection tool called Snort. And there are more actual deployments of Snort than any other intrusion detection tool. It is a network-based intrusion detection tool. And what it will do is if it sees a pattern of traffic going across the net that matches any of its known entries, then it will send you a message that looks like this. What happened with Snort, you can see in the upper left-hand corner that Rule 1913 fired, and that this is an RPC StatD UDP StatMon name format string attack. Any questions? What this means is RPC is a remote procedure call Many of you know what that is from your programming experiences. That enables a client to know how to communicate with a server and vice versa. It's using the status daemon, which is used for things like determining which version of programs and routines are in place. And UDP, it's using the user datagram protocol at layer 4 of the 7-layer OSI model. And it's saying that somebody's sending a specially formatted string to the RPC server because there is a bug, a programming error, that causes, when that string is accepted, it causes the program to go into an abnormal state. And in this particular case, because you can see attempted administrator privilege gain, priority 1, somebody would get root on this box or super user if they successfully sent this string to the machine then that was being attacked. And you get other information out of it too. You get information like the source IP address, the source port, the destination IP address, and the destination port. Notice I just made them up here. These are all RFC 1918 addresses, private addresses, so you wouldn't suspect somebody else had really been attacked out in real life. There's also a tool that was developed by a person who took a number of courses from me when I taught at UC Davis, and it's called CMDS, or the Computer Misuse Detection System. And what it does is it works on individual systems. It's host-based intrusion detection. And it's shown a series of events here, which you can tell immediately that are very suspicious. Why? Well, look at the times. It's very unusual when people do computing activity at 4:33 in the morning, although for computer science majors, I don't know. You know, they may still be up trying to get that assignment done. But notice that this activity does occur at a suspicious time, and it says, oh, by the way, the SU command has been executed, and if you know what SU really means, it really means substitute user. Does not mean super user, because you can SU to any account you want if you're root. It means substitute user. And after the person had entered the SU command, the program changed its privilege level, meaning that chances are somebody got root. And then there is an immediate modification in a file called etc shadow. For those of you who know Unix, you know that that is a common name for the real password file in Unix systems. And then there's a critical modification of a file called .rhost, and that sets up trusted access so that I can gain access to other systems remotely, possibly without using a password. And so obviously this is an attempt to create a backdoor once somebody has gained illegal access to the system. Well, I would love to have told you 5 years ago or 10 years ago, Dr. Spafford and I worked in one of the earliest intrusion detection systems many years ago. But I would love to tell you that intrusion detection systems will solve a lot of your problems. But I have learned that they are not sufficient. They're good, but they're not enough to be able to tell you everything you need to know. And for one thing, where you place an intrusion detection system will determine how efficient it is. If you have network-based intrusion detection, but you don't place it in certain subnets, it's not going to be able to place and pick up the data for that particular section of your network. And if you have other devices too, they actually record a lot of data that people often don't really even look at or analyze. Certainly intrusion detection systems might miss this other output. If you know anything about tools like the name of FragRoot and things like this, they're designed to trick intrusion detection systems into detecting certain output that goes over the network. But firewalls and routers will pick up this kind of traffic even though you've tried to fool the intrusion detection